If you're looking for the best 3D printers of 2020, then you've come to the right place. There are loads of reasons why you'd be looking to invest in a 3D printer, as they are some of the most exciting gadgets money can buy right now. The potential of the best 3D printers is phenomenal, allowing you to create products, or whip up spare parts, from your own home, office or studio. You'll need a bit of headroom for the Nobel, because when its cover is on, it stands nearly 2 feet tall, and the cover must be lifted vertically each time a print job is finished. In all, it measures 23.2 by 11 by 13.2 inches and weighs 21 pounds. Its build volume is 7.9 by 5 by 5 inches. You can access setup functions or print sample objects using a 2.6-inch, 4-line LCD on the front panel, in concert with a 4-way rocker switch with a central OK button. A home button on the same panel takes you to the main menu. The Nobel's 3 sample test objects, accessible through the menus, are worth printing out. The first one, a tiny goblet, is truly exquisite. Generally, though, you will be printing either over a USB connection from a computer or from a 3D object file saved to a USB thumb drive. The Nobel is just the second stereolithography-based model in the more than a dozen 3D printers that we have reviewed. Very few stereolithography printers are priced in the sub $4,000 range that we focus on. Stereolithography was the first 3D printing technique to be developed, and most printers that use this method are expensive, with many models running into 6 figures, although they have been coming down in price lately. The Nobel's maximum resolution of 25 microns is typical of stereolithography printers, while only one fused filament fabrication printer that uses plastic filament that we've reviewed has offered comparably high resolution. In stereolithography, an ultraviolet laser shines into a vat of UV curable liquid resin, tracing a cross-section of the object to be printed on the resin and, in the process, solidifying it layer by layer to form a printed model. Unlike an F printer, the Nobel's build platform faces downward. It descends into the resin tray, and the successive layers of resin harden onto it. Schools looking to get 3D printing into the curriculum for the first time will find this model an easy fit for several reasons. The 3D40 Flex is a snap to set up and use, and it showed good overall print quality with few misprints in our testing. Also, it employs user-friendly software based on the same Cura open-source platform that many popular 3D printers use. And it can connect via Ethernet, USB, or Wi-Fi, or by plugging in a USB thumb drive containing the source file to be printed. Dremel's decision to limit the Flex to PLA compatibility, although a deal-breaker for hobbyists or artists eager to experiment with some of the more exotic filament types, is a good one for educators wanting to teach their students 3D printing skills. An even more classroom-friendly variant, the Dremel 3D40 Flex Edu, includes the 3D40 Flex, plus extra build plates and 4 PLA filament spools. Also in the bundle, 30 lesson plans for grades 3 to 12, and a course on 3D printing in the classroom worth 4 hours of professional development credit for teachers. The 3D40 Flex is a sizable 3D printer, measuring 18.5 by 23 by 19.5 inches, slightly larger than the Dremel 3D45, and it weighs 44 pounds. It's a closed frame printer, with a clear plastic door in front that opens outward, and a clear lid on top that swings upward to open. This permits easy access to the print bed when needed, and it ensures safety when a print job is in progress. The 3D40 Flex's build volume is 6.7 by 10 by 6 inches, identical to that of the Dremel 3D45 and similar to the space in the MakerBot Replicator Plus. On the front panel, the printer has a prominently mounted 4.5-inch touchscreen. It's for use in loading filament, coordinating computer-free printing from a USB thumb drive, and executing other setup and connectivity tasks. The 3D40 offers a good suite of connection choices. You can print from a computer over a USB, an Ethernet, or a Wi-Fi connection, as well as from a USB thumb drive that fits in a front-facing port to the right of the display. Also, every Dremel printer can connect via the web to the Dremel Print Cloud, from which you can slice files to prepare them for printing, and launch print jobs. Most 3D printer manufacturers are startups, founded by enthusiasts, and are solely or primarily focused on 3D printing. Dremel, the venerable Illinois-based toolmaker, is a notable exception. The company primarily makes rotary power tools such as screwdrivers, drills, and sanders. Dremel has a stellar reputation as a tool manufacturer, with its products earning numerous editorial awards from popular mechanics and specialized tool and building publications and sites. Although 3D printers such as the 3D45 are far outside Dremel's traditional product line, power tools and 3D printers have one very basic thing in common: they're both used to make things. And Dremel clearly put the same care in designing and crafting the 3D45 as it does in making its tools. The 3D45 is a fairly large printer, measuring 15.9 by 20.2 by 16 inches, making it best suited for a table or a workbench, and it weighs a hefty 47 pounds. It's a closed frame printer, with a clear plastic door in front that opens outward, and a clear lid on top that swings upward to open. This permits easy access to the print bed when needed, and safety when a print job is in progress. The printer has a 5-inch touchscreen for use in loading filament, printing from a USB thumb drive and other tasks. On the right side of the printer are the on-off switch, a USB port for connecting to a computer via a cable, and an Ethernet port. The 3D45 offers enough connection choices to keep most any user happy. You can print from a computer over a USB, Ethernet, or Wi-Fi connection, as well as from a USB thumb drive. Although Dremel doesn't have a printing app per se, every Dremel printer can connect via the web to the Dremel Print Cloud, from which you can slice files, launch print jobs, and monitor prints in progress from the 3D45's onboard 720p camera. The Mini 2 and other Lulzbot printers are made by Aleph Objects, a Colorado-based company that is committed to Libre innovation, which means the hardware and software it creates is free to be copied, modified, and converted by all users. The black, steel-framed Lulzbot Mini 2 measures 24 by 18 by 13 inches with a 1 kg filament spool attached, and it weighs 26.5 pounds. It has an open frame, meaning that it has no front door, sides, or top. Its build area is 7.1 by 6.3 by 6.3 inches, 20% larger than that of the Lulzbot Mini but smaller than the area on the Dremel Digilab 3D45. Setting up the Lulzbot Mini is simple enough. You unpack it, and remove some foam rubber blocks inserted between components. You then download and install the software to your computer, and connect the included USB cable and power cord. When you open the software, a 3D test file, Rocktopus, is visible on the screen. The next step is to remove old filament from the extruder. Removing it, and adding a spool of fresh filament, is easily done once you've installed the Cura software by following the instructions in the Quick Start Guide. The hardest part of the process is squeezing hard enough on a clamp to let you remove or insert the filament. Like other Lulzbot printers, the Lulzbot Mini 2 uses 2.85mm filament, the thicker of the two most common filament diameters. The printer can work with a range of filaments that goes far beyond the acrylonitrile butadiene styrene and polylactic acid typically used in 3D printing. The Mini 2 has a spool holder on an arm that extends above the printer. It can fit most any size of filament spool. This is a strong point, as many 3D printers only fit their company's proprietary spools. Here, you can use third-party filament, as well. The only filament included with the Lulzbot Mini 2 is a 1 meter test length of the Poly-Lite PLA. The all-black Replicator Plus is large, measuring 16.2 by 17.4 by 20.8 inches, so it's best kept on a table or bench of its own. It weighs 35 pounds, 6 ounces. With a rigid yet open frame, it's open at the front, on the sides, and on top, permitting easy access to the print bed and easy viewing of prints in progress. Its build volume is 6.5 by 11.6 by 7.6 inches, 25% larger than its predecessors. According to MakerBot, it's also 30% faster. The Ultimaker 2 Plus has more symmetrical dimensions of 8.1 by 8.8 by 8.8 inches. The Smart Extruder Plus is a cinch to install or remove by snapping or unsnapping it, as it's held in place by magnets. What makes the Smart Extrude Plus smart? For one thing, it detects when you're out of filament and automatically pauses the print. Without it, you would have to scrap the print. It also sends notifications to the MakerBot desktop software and the MakerBot mobile iOS or Android app. The Replicator Plus has a good range of connectivity choices. You can print from a computer over USB, Ethernet, or Wi-Fi, as well as over Wi-Fi from a phone or tablet with the MakerBot mobile app installed. You can also print files from a USB thumb drive, which fits into a port to the right of the LCD. This is the most connection choices we've seen on a 3D printer. The new MakerBot print app is as simple or powerful as you need it to be. You can easily open a file and launch a print job, but you can also store and manage multi-component projects, and export files to USB keys or other drives for printing out. Standard resolution is 200 microns, you can switch to high, although standard gives good quality. MakerBot Mobile lets you control print jobs from a smartphone or tablet, and now has built-in CAD support. You need the app to set up the Replicator Plus, it links via a peer-to-peer connection to the printer.